there are a lot of open resource work, and people are more and more publishing their code, their data sets, and this is a very positive step towards transparency.
Hello and welcome to the AI Master Group podcast, featuring the people who are building the future of AI in their work today. I'm your host, Jim Griffin. Today, I'm very happy to have as our guest Dr. Marwa Kechaou, who's earned her PhD in machine learning from INSA, which is the National Institute of Applied Sciences in Rouen, France, which she earned in 2022. Currently, she's also a research fellow at LITIS, which is the Computer Science, Information Processing, and Systems Laboratory, which is connected to the Normandy region, of which INSA University is a part. Since that time, she's worked at places like Trax Retail, where she did image classification technology for retail on iOS devices, and also at Luxcan Weinig in Luxembourg, where she was focused on defects in industrial wood across different wood species. And currently, she's doing machine learning as the primary engineer at Alohi communications company, and we're going to learn more about that shortly. Welcome, Marwa.
Welcome, Jim. How are you? Thanks for having me on your great podcast.
Thank you also. I didn't mention it in the intro, but I actually know that you have a background in engineering as well as machine learning, which is what comes together for you when you're doing your applied research. Can you describe a little bit about the journey that led you to what you're doing today?
Yeah, thank you for your question. Actually, I started studies in mathematics and physics, in preparatory classes in Tunisia, which prepared me for very competitive exams to access engineering schools in France. And being passionate of images and photography, I decided to pursue specialization that involves image and signal processing. Where I had some let's say at the first 2 years theoretical courses of machine learning, but the real first contact with this was through an internship where I had to work on anomaly detection to control the packaging of food products using thermal camera. Actually, it's when you get your hands dirty, you learn what are the real challenges, and the optimized algorithms to solve these kind of problems. And I found a very cool machine learning approach helping me with this anomaly detection problem. And I started being more passionate about it. And following more online courses, mainly on Coursera platform. I remember, I found the great course of machine learning by Andrew Ng. Offered in collaboration with Stanford University, and also the specialization mathematics for machine learning offered by Imperial College London. Then this was a continuous learning process. There were a lot of great content online. There were the lectures of on computer vision, available on YouTube, offered by Stanford. And following this, I did one other internship in learning by the end of my engineering cycle. And I felt that I want to dive more into a research topic but at the same time apply these to real world data sets, because there are a lot of complex stuff different from the ideal public real data set. And that's why I chose what we call, a specific type of PhD. In France, it's called PhD CIFRE. That allows to have a collaboration between a company and the research lab at the same time. So, and this was, a great opportunity to make applied research.
Wow. Speaking of applied research, I mentioned just now that you're connected to a startup, Alohi. And I'm curious how that came about. How did they find you or did you find them? What's the story there?
That's right. I'm currently working as machine learning engineer at Alohi. Where we develop three powerful apps with over 4 million of users. These apps are Fax.Plus and Sign.Plus that streamline communication and agreement processes, and Scan.Plus, the app I'm currently working on. Scan.Plus focuses on secure AI, AI powerful document management and scanning. I actually found their job posting on LinkedIn, and when I went through the interviewing process, I was really impressed by their ambitious AI roadmap for their projects and their vision on how AI could drive innovation across their apps, which resonated with me, and I decided to join their great team.
So you found them and they found you on LinkedIn. There you go. A little plug for the LI. Excellent. Well, we're going to be looking forward to hear more about that. You know, one of the things that's interesting is, so you're doing this work now with this startup company, but I also mentioned in the intro that you're a research fellow. So I wonder, can you describe what that role entails, and in particular, how you balance the demands of academic life together with engineering work at a startup?
Yeah, okay. Thank you for this question. Actually, just to first introduce, what does mean research fellow, or let's say scientific collaborator also, this can be called this way in France. This enables young doctors to contribute to ongoing research projects in the lab, co-supervise students, or potentially lead industry-oriented research projects. Personally, I chose this role to, let's say, maintain my involvement into academia but without requiring full commitment to a lab or research institution. I had like many research ideas I couldn't work on during the PhD time, and I wanted to be a part of the lab, to also get access to their cool resources, including GPUs. For research project, especially when you work on deep learning stuff, this is very needed, and also the great network that is offered, the great network, that is offered by the lab, and this can be considered as a continuous learning process for me, and can be very valuable when you have an R&D position, for instance. But for regarding the second part of your question about this balance, actually being a research fellow, lets me explore advanced machine learning topics, and this can be very helpful when this can be applied. When these insights can be applied into real world products. This can, let's say, this becomes a natural synergy between the two roles, the research and engineering. And by the way, we met both in last September in Madrid for the announcement of YOLO V11 that was organized by Ultralytics, and my attendance was supported by Alohi through its personal development budget that allows each employee to attend these events or let's say research conferences to develop the research and the technical skills, and this can be beneficial for my both roles. So the research fellow and also the engineering role. But at the same time, I can't deny that this can be, challenging sometimes, particularly with challenging in a way to find this balance, particularly with the confidentiality requirements. So in a competitive field or landscape, it is normal that companies, let's say, restrict certain aspects of their technologies. And in this context, I choose to work on projects that don't directly overlap with the proprietary technologies. But of course, this requires careful, planning and working. Spending personal time on research, since also the engineering role is a full-time job. But if you are passionate about both roles, which is my case, fortunately. I see that the spending, this extra effort, let's say it's a blend of growth, professional growth, and personal development rather than a burden.
One of the things that also plays into this whole topic about the university setting, and you described very well the access to the resources and the continuous learning and some of those others. I know in that setting, there's a lot of pressure put on publishing. And for those of us who read those papers, I wonder, in your opinion, if there's any downside on that kind of pressure. For example, in deep learning, the results that get published are empirical, so should be possible to reproduce what's described in the paper, right?
Yeah. Yes, that's right. There is definitely a lot of pressure in academia to publish, and this, let's say, can be. This is a double-edged weapon, because on the one hand, it can drive rapid innovation, but also on the other hand, it comes with many downsides. Or unfortunately, this type of pressure, can prioritize quantity over quality. And I will take two examples. For instance, for generative adversarial networks, they have been a breakthrough in the field, and today there are so many papers making it overwhelming for researchers to keep track of the truly innovative work, and repeating similar ideas without significant advancement make it hard to discern which is the genuinely new or impactful. Also for large language models, this very exciting area, there has been a big surge in papers around prompt engineering, and I have read a lot of comments about this, that many papers, they don't present really innovative ideas, but rather than that, they just present small tweaks that are not necessarily advancing the theoretical foundations or let's say practical advancements of LLMs in a meaningful ways. So for someone who is trying to be on top of the field, this can lead to information overload. and it becomes hard to identify. To identify the research that pushes the boundaries. So that is said, this type of pressure is like in a way impacting the reproducibility of results, because it can lead to work that won't be thoroughly validated as it should be, and this won't help the results reproducibility. For deep learning, this is even challenging, because reproducibility depends on many factors, like the access to the exact data set, model configurations, computational resources, and the hyperparameters that the authors used. And small differences can lead to very different outcomes. For instance, I'm going to take the example of random seed that control the weights initialization of models in deep learning, the order of data shuffling, and other stochastic aspects of the training process. Their change can dramatically affect the reproducibility of the results.
You're listening to the AI Master Group podcast.
Their change can dramatically affect the reproducibility of the results. And for this, I recommend read the paper. I think Torch random seed is all you need. This is not really the exact title of the paper. It's even longer, I guess, but it was written by David Picard, and he presents like the impact of using different random seeds. How they can lead to different performances. So, we should like also mention that there are a lot of open resource work, and people are more and more publishing their code, their data sets, and this is a very positive step towards transparency.
That's interesting. I'm going to have to look up that paper. That sounds interesting, and it sounds plausible that the random seed itself could be. So obviously that doesn't help anyone if you're cherry picking the random seed to get the right result. That's not what we have in mind. Interesting. So we've got papers as one dimension, and then another dimension is the tools and frameworks that we use in our work. I know you've taught a course in a master's program in AI, which I think was about unsupervised machine learning. I guess you might have been focusing on topics like dimension reduction, many other things. So out of curiosity, what were some of the main tools or frameworks that your students used in order to complete their projects in that course that you taught?
True. So I had the opportunity to teach a course on unsupervised machine learning at the Virtual University of Senegal. And this course covered the range of topics, including dimensional reduction techniques like principal component analysis and the SMET distributed stochastic neighbor embedding, as well as clustering methods such as K-means and dbScan. And I wanted my students to use, let's say, tools and libraries in their projects that help them in their internships in industry. And the primary framework that was used, the Python, because it's a rich ecosystem of libraries for machine learning. They also heavily relied on scikit-learn for the implementation of dimension reduction and clustering algorithms. They also used Panda for data handling, Matplotlib and Seaborn for visualization. Fortunately, we didn't have time to use deep learning frameworks such as PyTorch and TensorFlow, like to handle more complex data. And models like autoencoders for the dimensionality reduction. But I believe overall, the tools, the combination of tools they used helped them develop a solid understanding of the studied methods.
Well, what you described is right down the middle of the fairway for a program like that. So no surprises there. Mm-hmm. So are there any emerging technologies that you've got your eye on that you're following closely at this time?
Yes, there are, many great, exciting areas that are evolving nowadays, and one of them are like the diffusion models. Are added a lot to the generative AI research. So these models that operate by reversing the process of adding noise to the data, help it to add more stability. Over the standard guns, let's say, and they are generating high quality images and are used in very cool applications like image editing, in-painting, restoration, and also video generation and animation. In addition to that, there are this combination of large language models and vision models that are helping in very cool tasks like customer support, also image captioning, like visual image, question answering, and so on. They are fortunately, there are more and more open source code of all of these models, and they are very also cool, let's say, demonstrations available on Hugging Face, for instance, to check how the outcomes of this model before their use, and this can help boost the rapid innovation of the field, and let's say democratizing AI by giving access to everyone.
Yeah, excellent. So you've got your eye on diffusion models and also LLM foundation vision models as well. Interesting.
Yeah, there are GPT-4 vision model, Flamingo, released by DeepMind and so on. So to be honest, there are a lot of new things, and it's a bit tricky to follow everything. So yeah, we do our best.
Yes, it is. Well, speaking of being difficult to follow things, it's always helpful to be able to collaborate and share ideas. If people want to share ideas or collaborate with you, how can they best get in touch with you?
To be honest, I'm more available on LinkedIn, my LinkedIn account, so they just can DM me and I will be available for sure. It will be my pleasure.
Aha, yes, you have a very robust profile there on LinkedIn. So that's great. Well, Marwa, once again, it's been great to be able to pick your brain about these topics. You're obviously on the leading edge. Thank you very much for joining us on the show today.
Thank you, Jim, for having me, and it was a very great discussion with you. Thanks a lot.
You've been listening to the AI Master Group podcast. I'm your host, Jim Griffin. Until next time, stay curious and stay in front.